Okay, so we just went through the warm-up exercises, and we're going to have to recall some of that information in the next couple of videos in this lesson. So let's continue from here. So right below the warm-up is the actual lesson. Now, these are three formulas: the Pythagorean theorem, distance formula, midpoint, that you have used before. But in case you were never shown, I just want you to see where these other formulas come from, and where they really come from is, well, the distance formula comes from is the Pythagorean theorem. We're going to see that a lot this year, that a lot of formulas we have come directly from the Pythagorean theorem. So let's start off from that. What we just saw was c squared is equal to a squared plus b squared. And if you want to solve for c here by taking the square root of both sides of the equation, this turns into c. Now, usually if we solve an equation, I'd put a plus or minus sign in front of the square root, but since we're dealing with the sides of a triangle, which are always positive, I don't have to put plus or minus because it can never be negative. So we're just going to keep it square root of a squared plus b squared. And that's what you have. It's kind of small on your paper, but that's what you already have right here. I'm just kind of leading you through where all this stuff comes from. Okay, so knowledge about this Pythagorean theorem that we did over here, where does this get us? Well, it gets us to finding the formula for the distance. So let's say we wanted to find the distance of this red segment with endpoints at the point A, which is x1, y1, and the point B, x2, y2. Well, first we have to find the coordinates of this point right here. That'll allow us to find the lengths of these two sides. So the coordinates of this point are, the x coordinate will be the same as this point up here because this is a vertical line. Okay, so this will be the point x1, and the y value of this point will be y2. Okay, so what is this horizontal distance here? Well, it's just going to be x2 minus x1. That's going to be its distance. Now, we don't really have to worry about too much here because x2, since it's to the right, is bigger, so x2 minus x1 will be a positive value. So that's no problem. Now, over here, the vertical distance of this line will be y1, and I don't know why I put a point right there, will be y1 minus y2. Now, why did I put these in a different order? Well, to be actually the correct distance, I had to take the bigger one, since this is higher. If you consider there's a coordinate plane here, this is further up, so it's y1 minus this y2. So that gives me a positive value. Now, when I go to transfer that over to our actual formula, I'm going to end up, you're going to see I'm going to switch these, and the reason is because we're going to be squaring it. It doesn't matter if y1, y2 is positive or negative, because when we square it, it will give us a positive value anyway. So where does this formula come from? The distance formula. So let's write this out. So the distance formula, the distance of this line, as you see from over here, I need a better color, from right here, this c, this distance c, is going to be the square root of this side squared plus this side squared. So in here, what is the distance of this side? Well, it's just x2 minus x1. And it's going to be that quantity squared plus this distance squared. Now, I could write y1 minus y2 in here, but I think that would be too confusing. I made sure that this value was positive, but it doesn't matter if you go y2 minus y1, because even if that is positive or negative, it doesn't matter. Once you square it right here, it will always be positive, because distance is positive, and you have to get that positive number in there. But just to help us remember the formula, I don't want to confuse you by writing in the different indices, the indices in a different order. So we can, and we are allowed to write x2 minus, or y2 minus y1 because we're squaring it. And there's our distance formula right there. Okay, the last formula we're going to look at is the midpoint formula, which you see here, and let's see how that is derived. So let's say we have a segment, and the endpoints are x1, y1, and the other endpoint is located at x2, y2. Okay, now if we drop down, again, a vertical and a horizontal line, and we make this right triangle, just to indicate that these are vertical and horizontal. Let's take a look at the, say, x values first. So right here, if we can consider that we drop down that vertical, then this x value right here is x1. And this point right here, if we drop that vertical and just continue all the way down lightly, that is going to be x2. Well, if you notice, take a look at this midpoint, which is right here. If you look at that, that point is not only in the middle of this segment, it's right, if you drop this down, it's right in the middle of the two x coordinates. Similarly, we're going to do the same thing over here. But if you look at that point, it's right in the middle. Now, how do we find the middle, that middle number in between two numbers? Well, that's just the average. And it's the average x value. So how do you find the average of two x values? Well, you add them, and you divide it by 2. That's finding the average. Okay, so we're going to say that this x coordinate of the vertex, we can call this x sub v. X sub v, meaning the x value of the vertex. That can be found by just adding up your two x values of the 2 points and dividing it by 2. And there it is, right there. Right there. That's the x value. And similarly, the two y values, if you run some horizontal lines over here, and this is going to be y2 and this is y1, you can see that that point is right in the middle of y1 and y2. So again, all we have to do to find the coordinates of that point, we'll do that up here, is the y value is just add up y1 and y2 and divide it by 2. That's how you find the average. It's really that middle number. It's right in between. It's just really the average. y1 plus y2 over 2, and there's that. And I guess we should call this, since we call this one xv, we can call this y sub v. So meaning the y value of the vertex, okay? And now we're going to be doing some examples using the 3 formulas that we just went over.